So, all right, so here we go. It's very, very easy to find the inverse. That's what this solution means. So if we have a function that adds 2, any guess what the inverse will do? Subtract 2. Now, some of you, that is going to make perfect sense to. Others of you are going to be like, I want something to write down. So I'm going to show you these steps, algebraic steps, that you can always go through to find your inverse. Okay? You may not always need to do that, but here are the steps. Here was my original problem. I'm going to rewrite it as y equals x plus 2. Because we learned last year in Algebra 2 that f of x is the same as y. So I'm just going to write it with y. Now, inverses flip-flop your variables. So I am going to make this an x and this a y. All the x's become y, all the y's become x. That's the inverse relationship. Now I'm going to solve for y. And do you see what happens when I solve for y? What do I end up with? Exactly what I thought the inverse would be. Okay, so one more time. If you want to go through the steps, switch your x and y and solve for y. And that will give you your inverse. So let's try that with the next one. Now you may have a thought about what the inverse is, and that's great. You can do this in your head. But I'm going to go through the steps just to make sure everybody has, that under your belts here. So x equals 3y plus 1. Step 1, switch variables. Now I'm going to get y by itself, so I'm going to subtract 1 and divide by 3. So my inverse, and I'm going to go ahead and use my correct notation, my inverse is x minus 1 over 3. Now, I'm going to show you something. This is what it means to be an inverse, okay? London, pick a number that's not too big. Pick a number. Pick one. No. Just a number.
8.
8. I want you to look at the original problem. If we put 8 into the original problem, what did we get out? What came out of that? We put 25. So 8 comma 25. We put in this x and we got this y. Alright? Now let's come down here. What happens if we put that 25 in right here? I get my 8 back again. That's what inverses do. They undo each other. So this becomes 25 8. That'll work here. And that would work for any number, not just 8. Okay. What's C look like? Oh boy. C is a little bit tougher.
Oh, God.
You can handle it though, I'm confident. So let's talk about, walk through our steps here. So I'm finding the inverse. What's the first thing I need to do? Switch my
Variables.
variables. Yeah. Okay, you might want to write these steps down if you're having a hard time remembering. So x equals 2y minus 3 over 5y plus 1. Now, I need to get y by itself. This is going to be a little harder. Does anyone have an idea?
Multiply the bottom.
Oh, multiply the bottom over here. And groupies, when I do that, isn't that going to be a distributive? I'm going to multiply this over to here. so I'm gonna have 5xy plus x equal 2y minus 3. Everybody good? Follow that
Yep.
move? Now, I'm trying to get y by itself. Please don't add 3 and divide by 2, because that would give you y equals, but why isn't that going to be good? There's a y on the other side, okay? So we somehow got to get these y's together. We can't have y's on both sides. Oh wait, you can't have y's on both sides. So maybe I should bring this guy over here and this guy over here, because then what I will have on this side is just the y's, and what I will have on the other side is the things without y's. Does that make sense to you, Ronan?
Do you have X's on both sides?
Yes. Remember, I'm solving for y. Now, once you get them both on the same side, I'm going to factor them out. And now, Jake S., I don't have 2 y's anymore, do I? Now I have 1. I factored it out. And if I'm solving for y, I'll divide by the parentheses. And if I use my correct notation, because I want us all to be A+ students, that is going to be my answer.
Can we change that to x plus 3?
No, you can't. Now, that's a good question. You can't, here, I shouldn't say no. You can change that to x plus 3. But then your bottom would have to change to negative 5x plus 2. So in other words, you can't change just the signs on the top. You have to change them all. And that would be okay. That would be perfectly okay. All right, let's run through those steps again. This is probably going to be a test question. That'd be my guess. So what do I need to do? First of all, I switch my variables. Then I move that denominator over, which you all knew to do that. Distribute. And then here's the step we got to remember. Since we're solving for y, we have to get our y's on the same side. So we rearrange stuff. Right?
Yeah.
Okay. All right. How about D? D looks different. Your job is to find the inverse. So here's the problem. What do you think? How do we start?
Square both sides.
Wait, how do we start?
Oh,
We're
switch
gonna
variables.
switch our variables. That's what gives you the inverse. That's switching x's and y's. Okay, now we'll square both sides. So x squared equals, remember when you square a square root, and then we'll add 4. Uh-oh, somebody's phone ringing. So our inverse, if that's your phone, go turn it off. Oh, never mind, it went off. Oh, nope. Is that yours, Ryan?
No, should I check?
I don't care. I mean, if it's done, that's gonna drive me crazy. We okay with this?
Yeah.
What do you think about E? E isn't even an equation. E is just a set of ordered pairs. What do you think the inverse of that might look like?
2, 1, 4.
Oh, yes! You guys should be teaching this class. The inverse is 2, 1, 4, 3, 6, 5, and 2, 7. Why is that? Because what do inverses do? switch x and y. Whether it's in an equation or in an ordered pair, you switch x and y. Beautiful. Now, one thing to notice here is I have to be really careful about this notation. Take a look at this set of ordered pairs after I switched them. What do you notice about that point and that point? They have the same x. And what do we know about functions? It's not, this is not a function. Is this the inverse of this? Yes. But it is not a function. And that brings us to the next conversation, which is, are these things one-to-one? If you are going to be one-to-one, then you have to be a function, and your inverse has to be a function. So this guy that we just did would not be one-to-one. Because again, I'll say it again, to be one-to-one, you are a function, and your inverse is a function. That means 1x, 1y, right? Nothing repeats. So let's look at these pictures we've got, which, by the way, some of you are still a little weak on your BFFs. What's this one?
Forever.
I know it's
X squared.
X squared. This one is nothing, not a BFF, it's not function, right? What's this one?
Square root.
Square root, and this one is cubing, x cubed, yeah, all right. Now, the question is this one-to-one?
Yes.
Okay, now wait, I heard some yeses, and I'm okay with you guessing yes, but let's talk about why you're wrong. Is this a function? This picture right here, is he a function?
Yes.
Yes, so the original is a function. Now, inverse it. The inverse would not be a function. I'm going to show you something. If I draw in this line, for example, this point right here might be the point 2, 3, and this point over here would be the point -2, 3. Does that make sense to you? If I do the inverse, I'm going to turn those ordered pairs around. And what's going to happen when I turn them around?
Same x's.
I just say x's. So the inverse is not a function. You all are familiar and comfortable with the vertical line test. The vertical line test checks for repeated x's. What does the horizontal line test check for? Repeated y's. And if you're going to be one-to-one, you can't have repeated anything. Okay? No x's repeat, no y's repeat. Which means if you're going to be one-to-one, you got to pass the vertical line test and you got to pass the horizontal line test. No x's repeat, no y's repeat. Okay, how about this guy, one-to-one? No, he fails the vertical line test, which means he has repeated x's. His y's are good, but not his x's. One-to-one? Yeah, passes both. No repeated x's, no repeated y's. So, a question might be on the test, is this one-to-one, why or why not? You're going to say yes, it's one-to-one, and then what is going to be your reason? What are you going to say? Passes both tests. You can say it passes both vertical and horizontal tests, or you can say there are no repeated x's and there are no repeated y's. How about this guy? Cubic function. 1-1? Yes. Yes, in 1-1. Bless you. Now, someone has claimed that these two things are inverses. And it is your job to prove that. okay? Now, I'm gonna preface this by going back to what London said, or London offered me a number. And I put that number in, she said 8, so I'm just for fun, I'm gonna put 8 in. If I put 8 into F, what do I get?
Oh, an extra
If I put 8, what do I get? 26. Now I'm gonna take that 26 and put it into G, and what should happen? If they are inverses, I should get my 8 back again. So 26 minus 2 over 3, 8. Now, that's what it means to be inverses. But guys, that is not a proof. That is not a proof. I think it's right, because it worked with 8 and 26, right? That worked. But that can't be considered a proof. To be considered a proof, you have to build this composition and this composition. Alright, and some of you are a little shaky on this too, so this will be good review. What does this mean? Take the G and plug it into F. Okay, let's do that. If I take the G, this is the G, and I'm gonna plug it into F. Is that okay with everybody? So I'm gonna have 3, x minus 2 over 3, plus 2. Don't be scared with the mess that we've got here. Aren't these just gonna cancel? So what have we got? X minus 2 plus 2, which is x. So in the beginning, I started with an x here. And I did my stuff, and what did I end up with? An x. Now we gotta do it the other way too. Believe it or not, we don't run into them in this class, but there are things that are inverses, that are left inverses, right inverses. We need to check both directions, left and right, okay? So this means take F and plug it into G. So here's F, and it's going in here. What happens with these? So we have 3x over 3, which is, if they are inverses, you guys, when you build both compositions, you have to end up with x. If you end up with anything else, you're either wrong or they're not inverses. You gotta have x. Okay, would you try B? It is the same exercise. Who is yawning?
Joe.
Joe is yawning?
That was me.
Let's go. You need to build both compositions. Dana, you wanna come up and build this one for us on the board? Okay? And then I'll need somebody to build the other one. Good? You can do it. Bring him with you. You guys can do it as a team. Come on, let's go.
Wait.
That's right, you're putting F, which is 2x minus 7 over 5, into G, so you have to now add 7 to that. And, yeah, there you go, now simplify. Yeah, it looks weird, but we're not frightened by it. Charles, are you working? So we'll simplify it. if I do the first one and it doesn't come out to be X, then there's no point in doing the second one. Unless you just wanna kind of check to make sure. For us, with our problems that I'll be giving you, if one of them equals X, the other one should also equal X. Okay, we're gonna have just normal problems. So you need to do both, make sure they both come out to be X, but they are not. Okay, Dana, did yours come out?
Yes.
It's only 4 points.
To score.
So if you would do, you still.
They only get 4 points. There's no score.
Oh, I mean, I don't, it doesn't really matter for me, I just have to press someone.
And something has to be.
Four's not here yet?
I don't know if she's coming. Powder puff.
What?
She said she's sick.
All right, you good with that, guys?
Oh my god.
Who's your back?
Okay,
I don't know if we have one.
everybody should have gotten X, and the
Just
guys
can't
on the
have it. It
board
has to be flawed.
have it. All right, we got 5 minutes, gotta get through this next thing, here we go. Switching gears, section 1.5 has 2 topics in it. One is inverses, we've done that. Now we are going to do number 4. These are called parametric equations. You guys in physics, you may have encountered these because they are used a lot when we describe how an object is moving or where it is located after a certain amount of time. So parametric equations, always x equals, y equals, and then some stuff involving t. That's what they look like. The first question says, find the points determined by these t values. Now, you can set this up however you want. To keep myself organized, I'm gonna set it up in a t-chart, just like I've done, you know, when I'm figuring out points by y. But this time, I'm not figuring out just an x or just a y. This time, I'm figuring out both. And guess how I'm gonna figure out if t is gonna be -3. Guess how I'm gonna figure out my x and my y? Plug it in. So x will be, remember, t is -3. So x will be -2. And y will be 3. And this is kind of redundant because we're going to do exactly the same thing for all of these. All right, so now we put in -2. -1. And 0. And 1. I have no idea if I'm doing this right. I hope I am. Is that okay with everybody? Everybody understands that concept?
Yep.
That if we know a t value, we can figure out an ordered pair?
Yep.
Okay. T, oh my lordy. Find the direct algebraic relationship between x and y by eliminating the parameter. T is called the parameter. So basically, what this problem is asking me to do is eliminate t. Get rid of t. So x minus 1 equals t, Elisha, is that what you're saying? Okay, that's true. What do you want me to do with that? Why did I do that? And now what can I do with the t by itself? Plug it in, I love it. He says plug it in. Look here, guys. Look here. If t is x minus 1, which it is, he said that means you can come down here to this equation and put in x minus 1 for the t's.
Yep.
Now, look at that equation right there, you guys. Are there any t's in it? That is called a direct algebraic relationship between x and y. That's a fancy way of saying, write me an equation with x's and y's. Beautifully done. I'm gonna stop there tomorrow, or whenever I see you again. We are going to sketch that.
You're just a flood of those.